functional dependency. First, we have to apply the decomposition rule. First, we have to apply the decomposition rule. Decomposition rule nothing but splitting rule, right? Splitting rule. First, we have to apply the decomposition rule or splitting rule to where on the given functional dependency. But we can apply the splitting rule only on the right hand side, not on the left hand side, right? I explained in the inference rule. We can apply this functional dependency or decomposition rule on the functional dependency which is on the right hand side part, not on the left hand side part, to make the right hand side as a single attribute. Single attribute. This is the first step. I'll explain with an example. Okay. First step is what? Decomposition. We have to apply decomposition rule on the given functional dependency that is on right hand side to make that right hand side as a single attribute. That is the first step. We have to make sure that functional dependency that is on right hand side functional dependency should have a single attribute so that we can apply the second step. So step 2, remove extraneous attribute. Extraneous attribute. Remove extraneous attribute. Okay. Then 3. Step 3, remove redundant attribute. Redundant attribute. We have to follow these 3 steps. We have to follow these 3 steps to find out the minimal cover or minimal set or canonical cover on the given functional dependency. Okay, I just explained with an example. Right, so what is minimal cover or a minimal set? This is given in algorithm. So I just explaining, instead of explaining the algorithm, I'm actually taking with an example. Okay, so F1 you're having extraneous attribute or redundant attribute, nothing but you are taking any of the functional dependency F. We want to make that as a minimal cover. We have to find that minimal cover on the functional dependency, that is F dash. It should not have, if you saying that the given functional dependency is a minimal cover, it should not have extraneous attribute or redundant attribute or redundant functional dependency. If that functional dependency doesn't have these 2 on the functional dependency, that we say it as a minimal cover. How to make the given functional dependency as a minimal cover? We have to apply these 3 steps. One is decomposition rule, splitting rule on given functional dependency that is on right hand side to make single attribute. Second one, remove extraneous attribute and remove redundant attribute. Right. So we will take an example. I'll just explain with an example. Okay. They will ask a question like this. A relation R ACDEH. The given relation R ACDEH satisfies the following functional dependency. Satisfies the following functional dependency. Sorry, I have missed the B here. A, B, C, D, E, F, H. Okay. A, B, C, D, E, F, H satisfies the following functional dependency. What is the functional dependency they given? A, B determines C, C determines A, B, B determines C, then A, B, C determines A, C, then A determines C, then A, C determines B. This is the functional dependency they have given. We have to find the canonical cover on the given functional dependency. Okay, for relation R, A, B, C, D, E, F, H satisfies the following functional dependency. They given the functional dependency here. Question: find the canonical cover for this set of functional dependency. Right, to find the canonical cover, what we have to do? We have to apply those 3 steps. First step, apply decomposition rule on the right hand side. Second, remove extraneous attribute. Third, remove redundant functional dependency. Okay, first step, you just apply the first step, each 3 steps on the given functional dependency. What is the first step? Apply decomposition rule on the right hand side of the given functional dependency. What is the right hand side? C, A, B, C, A, C, C, B. We can't apply decomposition rule on the left hand side of the given functional dependency. Right? So apply now. A, B determines C. So to apply decomposition rule, we don't have set of attribute at the y side. We have only a single attribute, so no need of applying decomposition rule. So keep it same. AB determines C. Next, at the right hand side, we have multiple attributes A and B. Apply decomposition rule. C determines A, one attribute, one functionality. C determines B, second functionality. So with the help of C, I can find out A. With the help of C, I can find out B. So the C determines A, C determines B, right? So we are splitting that one. But result will be remain same. There will be no effect to the result. So C determines A, C determines B. Decomposition rule on the right hand side. Okay, determines AC. So ABC determines A, then ABC determines C. We have applied the decomposition rule over here. Next, A determines C, AC determines B. See, here we have what set of attribute at the left hand side. So we are not applying decomposition rule here. This is the first step. What is the first step? We have to see that the right hand side attribute should have only single value. Right? The right hand side attribute should have only the single value. To make that, we have to apply the decomposition rule. So after applying the decomposition rule on this given functional dependency, we got this as the result for this functional dependency. Yeah. Right. Next, step 2. We have what is step 2? Remove extraneous attribute. Extraneous attribute means the attribute is all with the help of one attribute. I can determine the other attribute. See, just taking the same example. AB determines C, C determines A. The same thing I have written here. Right. See here, AB determines C, right? What the meaning of this one? The combination of A attribute and the B attribute determines C, right? Nothing but B can alone determine C, right? Why I need A? B can alone determine C. Why I am saying that B can only determine C? Because I have one functionality, right? It is B determines C. With the help of B, I can easily determine C. Then why I need A? This is the extra attribute, right? This is the extra attribute in this functionality. So we have to remove. So you have to remove this A attribute. This is the extra attribute in the given functionality. So with the help of B, I can easily find out the C. Then why I have to combine this A with B? This is the extra attribute for this functionality. So I'm going to remove this A. So B determines C. Right? We have to find out like this. Next, C. ABC determines A. ABC determines A. At the right hand side, I have A. At the left hand side, I have A. Right? So I can, with the help of trivial functional dependency. What trivial functional dependency says? X determines X. An attribute can determine itself, and Y is a subset of X. Here you just apply the second condition. Y means A is a subset of ABC. Means I can easily find out, I can easily remove this attribute, because I can easily find out, means that trivial functional dependency is always valued in the given table. I will repeat. That's why I said trivial dependency is very important. You just understood. You have to understand that concept clearly, right? What trivial functional dependency is? Trivial dependency always valid in the given table without checking the functional dependency on the table. So here ABC determines A. Trivial means what? X determines X. Y is a subset of X. So here A is the subset of X here. Y is the subset of X here. So this is the trivial functional dependency. So this dependency is always present in the table. So no need of mentioning. So remove this one. Remove extraneous attribute. Same way, ABC determines C. Here C is a subset of ABC. So we can, with the help of trivial dependency, I can remove this one. Next is what? A determines C, then AC determines B. AC determines B. You just see here, C determines B, right? We can find out the B with the help of C. then why I have to use A? Why I have to combine A? Right? I can remove A here. C determines B. Right? C can alone determine B. Then why need combination of AC? So I can remove A here. C determines B. Understood? This part. Then I will take this one. Okay, see here. AB determines C, right? We have considered B determines C. So I have removed A because with the help of B I can determine C. I don't need A attributes, so I remove A attribute. But I have one more functionality called A determines C. If you consider this one here, we have to remove, we have to discard B, not A. A determines C. Now there the result will be different. The result will be different. If we consider this functionality to remove the A from this table, to remove extra attribute from this functionality, we're going to remove A. But if you consider A determines C, we're going to remove B, right? If you consider this one, we will get B determines C. If you consider this one, we will get what? A determines C. Okay. So which functionality we are going to consider? Depending upon that, we are going to get the result. So for this functional dependency for canonical or for candidate key, you all will not get the same answer. Each answer will be different. How we are thinking, how we are applying the rules, depending upon that, we are getting the result. Okay, this is about the second step. Remove extraneous attribute. Okay, we have to compare the given each functionality with the other functionality. If that functionality is there, with the help of the functionality, we can find out the given functionality, so we can discard that, right? And if you find like this attribute functionalities, it is always a trivial functional dependency. It's always valid, so no need of writing in the functional dependency. So we can remove this one. These are all the what? Extra attributes. These are all extra attribute. We have to remove the extra attribute in the second step. After removing extra attributes, we got B determines C, C determines A, C determines B, B determines C, D determines C, and C determines B. Now we have to remove the redundant functionality, redundant functional dependency on the table. Second step, removing the redundant attribute, nothing but extra attribute. In third step, we are going to remove the redundant functional dependency on the result of the second step, right? So what is resultant redundant functional dependency? We just see here B determines C. Here we have B determines C. So we have the same value. It is repeated 2 times in the functional dependency. So one attribute, one functionality we can remove. One function this functionality we can remove. B determines C is I have discarded this one. Next, C determines A. How to find out C determines A? See, we have to take the attribute closure. We have to take the attribute closure of the left-hand side value. Attribute closure of the left-hand side value. I am checking this part. C determines A. So we have to take the attribute closure of this part, right? So C plus. While taking the attribute closure for this functionality, we should not consider this. I am repeating. While we finding out the attribute closure for this part, for this functionality, right? For comparison, we should not consider this value because we are going to finding out this is a redundant functionality or not, functional dependency or not. Okay, so C plus, we just leave this one. So attribute closure of C is what? C. Attribute closure of C is C, nothing but reflexive property. So don't consider this one. C, yeah, C is there. With the help of C, I can find out what? B. With the help of C, I can find out B. Okay, then with the help of B, I can find out C. So C is already there. I am not writing. Right. So only CB. Are there any other attribute are there to find out? No. CB. Okay. This is the what. And we have to check in resultant of this attribute closure, the resultant for this attribute closure C plus, do we get A? Is A is there here? If A is there, then we have to discard the we can consider it as a functional redundant functional dependency. I will repeat. In this resultant of the attribute closure, if we got the right hand side value, then we can discard, then we can remove that. We can say it is as a redundant functional dependency. But in this result, we didn't get A here in the resultant of the attribute of C plus. So we have to write C determines A. Okay. Then now we have to check this one. C determines B. While checking for this functionality, we should not consider this for comparison with the other functional dependency. So attribute closure of C determines B is what? C plus, right? So C is the reflexive property. With the help of C, I can find out A. With the help of C, I can find out A. So A I have written. With the help of A, I can find out C. C is already there. Right, with the help of C, I can find out what? A. So A determines C. C is there, but C is already there here. Next, C determines B. So CAB. CAB. Okay, CAB. Now we have to check this resultant of this attribute closure C plus. Whether in this result we have this value, this right hand side value. C determines B. Yeah, CAB, we have B, right? So this is the redundant functional unique functional dependency. So we have to discard this one. C determines B, we want to discard, right? So switch to next one. We have to check the attribute closure of this one. B determines C. So B plus, that is we have to consider the left hand side value. B plus is equal to reflexive property B. With the help of B, should we find out any other value? No, because this is already discarded, right? We already discarded this one, so we should not consider this one. We are checking for this one, so we should not consider this one also, right? So for resultant of this one, we got only B for this attribute closure B plus. Whether B is there in the right hand side, no. So we have to write here. This is the unique functional dependency. Like that, you have to check for A determines C. Check the left hand side attribute A plus. Attribute closure of A at A plus is what? Reflexive property is A. With the help of A, I can find out C. With the help of C, I can find out B, A, C, B. So in these three values, the right hand side value is there. Yes, it is there, C. So discard this one. Remove this one. This is the redundant functional dependency. Check for C plus. C plus is equal to C comma A. Why? C is a reflexive property. With the help of C, I can find out A. We can't consider this B because this is discarded one. We have already discarded. We have removed. So only the present functional unique functional dependency is what? C determines A. So C, help of C, we can get A. Whether this A is there at the right hand side, no. So this is not a unique functional dependency. We have to discard this one. After discarding, what functionality we got? We got only C determines A and B determines C. These two are the unique functional dependency. After removing extraneous attribute, after removing redundant functional dependency, what we got, right? These two are the unique functional dependencies. This we say it as a canonical cover or minimal set or irreducible set of functional dependency.